In this section, we will learn KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law and Kirchhoff's voltage law. Before that, let's first think about what is open, what is short. When you have an open in circuit, then there's no current goes through it. So you don't have current. All the current will be zero. If you have a closed circuit, we call it short. If you have a short circuit over here, then voltage across a short will be equal to 0. Because we assume when you get to a short, then you only have wire connect from here to here, and we assume wire has 0 resistance. First, let's define node. Node is defined as electrical junction of 2 or more circuit elements. So, in this example, let's look at how many nodes we have. Obviously, this is a node because this is a junction between this element and this element. Now, how about here? Here is a node. Here looks like another node. And number 4 looks like another node. But there's a rule. If nodes are connected by using pure wire, then we consider that is one single node. So actually, node 2, 3, 4 together is only one node. So similar things over here. Even though it looks like you have a node here, 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 but actually those nodes are connected by using wire. So they are only one node. So in this example, we actually have only 3 nodes. That is A, B, C. Now let's see loop. Loop means closed path. So let's count how many loops we have. 1, 2, 3, 4, 5, 6. This is the exercise. Please count how many loops and how many nodes in the circuit below. Answer, there's 6 loops. Where are the 6 loops located? There's one loop here, and another loop here, 3rd loop, 4th, 5th, 6th. Now, how many nodes in the circuit below? This is one node. Remember, looks like there are 1, 2, 3, 4, but since they are connected by using wire, so this is one node. And here's one, here's another one, this one, that's it. So overall, we have 1, 2, 3, 4 nodes. Now let's look at Kirchhoff's current law. The Kirchhoff's current law is defined as the algebraic sum of the currents entering a node is 0 at every instant. Or you can say the sum of the current entering a node equals the sum of the currents leaving the. Now we use this video to demo Kirchhoff's current law. In this circuit, you see we have four components over here. We have a current source that is 1 ampere, and we have 1 k ohm resistor, another 1 k ohm resistor, and 2 k ohm resistor located over here. And in the circuit, you can see I inserted 3 current meter in the circuit. Pay attention. Current meter, when you connect a current meter, you need to connect a current meter in series in the circuit, because the current must flow through the meter, then the meter can tell you what's the current value. So now, let's review what is KCL, Kirchhoff's current law. Kirchhoff's current law is talk about for a node like this node. For a node, the total current into the node is equal to the total current leaving the node. So now let's run this circuit. Yeah, pay attention to this node. Let's see what will happen. Okay, now I write. Now let's check the current value. Okay, can you see here? This is the meter 1. The current meter 1 shows 1 ampere, and those two, one go down, one go this way, that is leaving this node. And if you add those two together, those two currents together, you will see their value is exactly equal to this current. This shows for a node, total currents into the node is equal to the total currents leaving the node. Now let's see this exercise. Please try to use KCL to solve the problem. Suppose there's a circuit like this, and I put 3 meters here, current meter. And the first meter shows 2 amperes, second meter shows 1 ampere. And what should be the reading on the third meter? Let's first define this node. We can call it node A. 3 branches connected to these nodes. 2 amperes in, and the 2 other currents leaving. One of them is 1 ampere. So how about this current? Based on KCL, total current in, 2 ampere, is equal to total currents leaving the node. So from this equation, you can solve the unknown current should be also 1 ampere.